Dr. Mitch.
Oh, okay. Well, everybody, this is a kind of an odd thing. Can you all hear me? Relio, can you give me the thumbs up that you can actually hear me? Okay, good. All right. I don't think I've ever had a talk go quite this way, but we'll make do. This will be fine. I'm a teacher at Western Connecticut State University. I have taught online for, well, since the beginning of the pandemic, and still give public talks on occasion this way. And so this shouldn't be too much trouble. I encourage any of you who are interested to come visit us at Western. You can contact me. I'll post my email, or Aurelio can give it to you. And you know, if you want to bring your kids to see WestCon, contact me and I'll give you the tour. Back in 1968, I remember 1968, I'm old enough. The Apollo 8 astronauts took a trip from the Earth to the moon, took a couple of laps around the moon just to check out all their equipment, because in 1969, another crew would be landing on the moon. One of the things they did, which was the first time in history, was that they actually got far enough away from the Earth to take a photo of our planet so that it could be all in one frame. And it gave us some of the most beautiful photographs we had ever seen before. This is one taken as the spacecraft was rounding the moon, orbiting back in the direction of Earth. I don't know if it was ready to come back yet or not. And so you got to see Earthrise. No one had ever seen Earthrise before. And it's a fascinating picture. They've done a little bit of cleaning up to get the 3D effect on this. But one thing that you can see from this photograph is how absolutely beautiful the Earth is. I think that's a perspective that we don't necessarily see here in Connecticut or wherever we happen to be from. I'm sitting here in my home in Bethel, speaking to you. One of the things that people sometimes get confused, and I try to try to clear it up at the beginning of my talks, is the difference between climate and weather. Climate is the statistics of temperature, humidity, atmospheric pressure, wind, and all these things, all the things we associate with weather, but over a large area and over a long period of time. Statistically speaking, if we want to make some sort of conclusion about the weather, we have to have probably 30 years worth of data to do so. These days, of course, we do have plenty of data, so that's not too much of a problem. Weather is basically what you see when you look out the window, which from my window looks like it was pretty clear, maybe a little clouds coming in, but it's not very windy, there's no rain and so on. That's weather. It's happening over a short period of time over a small area. Okay, so the difference is scale between climate and weather. Weather is what you expect, climate is what you expect, but weather is what you get. Now, you probably heard that the temperatures, and you've not only heard, but you've experienced, the temperatures are getting warmer year by year, but it's not every year, and it's not it's not every year, 1 year warmer than the next, but it's very clear that since we started collecting data, which was around the year 1800, our temperature has been changing. And if we look at the last 3 years or so, The temperatures have gone from 2018 to 2019 to 2020, and 2020 is either tied with or approximately tied with 2016 is the warmest year on record. 2019 was just a little bit lower. We don't know what 2021 will come in as, is because we're not finished with it yet. But you can see that the 10 warmest years in history, since we started measuring these things and collecting the data to calculate global averages, all those warmest 10 years have been since 2005. Another way to look at this is to look at individual years. This graph goes back to 1850 or so. Each red dot is a global average temperature. Mean and average mean the same thing in the way statisticians talk. And you can see that particularly since the 20s, the temperature's been going up fairly steadily. There was a kind of a flat part, immediately from about 1940 to 1950 or 1960. And I suspect that that's probably regrowth of forests pulling CO2 out of the atmosphere after World War II, but I don't know for sure. But you can see that the trends are going higher. Now, you notice that one year isn't necessarily warmer than the previous one. They go up and down a little bit within the trend. And that's for a variety of reasons, including whether it's an El Nino year or a La Nina year, whether there is other temporary sorts of events like volcanoes erupting that year or so on. Yet another way of looking at the temperature is looking at it for 1 year, but looking at most of the Earth's surface all at the same time. And this is in 2020. Any little squares that are blue are cooler than the average from 1951 to 1980. Any that are red are warmer, okay? And so anything that's white is equal to the average. Amazing things you can see here is one is of how little blue there is. There's a little dab down there on the coast of Antarctica, but look how hot northern Siberia was. So that's just an area of the world where you generally don't have heat domes, but they had a hell of a big heat dome there in 2020. And that's dangerous for all sorts of reasons. One is that there's a lot of, people there aren't equipped for hot weather. And there's a lot of permafrost up there that melts. And when the permafrost in the soil melts, it releases methane, which then increases warming. So that's a bad thing. Well, here's another one more graph before we move on to other things. And this basically shows for 2020, the nations of the world, any of those nations that are blue, and I don't see any, are cooler than the average. Any of them that are yellow, orange, and red and brown are warmer than the average. Any of the countries that has a black circle around it had the warmest year in recorded history last year. And you can see there were a lot of those, including Honduras and Jamaica, and Belize, and Taiwan, and so on. It was a hot year last year, any way you look at it. Now, one of the reasons why it was hot is because the amount of carbon dioxide and other greenhouse gases in the atmosphere has been increasing. And if we look at CO2 over the last 150 years or so, like we were looking at the temperature, we would see a zigzag that was constantly moving up. Sometimes people are concerned that maybe we're exaggerating, and the fact that carbon dioxide's gone up and down in the past makes it mean that we shouldn't be too concerned about this one. Well, this graph pretty much lays that to rest. You can see the 1950 level, about 300 parts per million, and you can see where we are now. And you can see that we haven't had a CO2 this high since mastodons roamed the earth quite some time ago. As of a couple of days ago, we had 413 parts per million of CO2, and a year ago was slightly less. Now, there are websites that actually give you this kind of information if you're interested. If anyone's interested, I'd be glad to send you the address for that particular thing. Now, it's not just a matter of temperature at the surface indicating the climate is changing. There's all sorts of things that are being measured by scientists in different parts of the world, some of which don't even know each other. For instance, the amount of snow cover is decreasing. The spring is coming earlier. The species are migrating farther north and upward in the mountains. The temperature over land is warming, the humidity is going up, the sea ice is going down, the sea level's coming up, and so on. If you want an indicator of a warming world, you really have to look no farther than the fact that the ice is melting. If the world were not warming, the ice would not be melting year after year after year, but it is. What we have, though, is a whole bunch of different independent lines of evidence that are all pointing in the same direction. All these things are measurements that are collected independently. None of them is used to calculate the others. They're collected by different scientists in different parts of the world, and including some that probably don't even like each other or they're rivals or whatever. And yet they're all pointing in the same direction. Scientists will consider this something called consilience. And when evidence from independent, unrelated sources converge to strong conclusions, that gives us a great deal of confidence that what we're saying is accurate. Unfortunately, none of us like it the way it is. All right, so we have all this heat coming into the atmosphere. Where is it? Is it still in the atmosphere? Well, 93% of it is in the oceans. If you took physics back in the day, you may have learned about something called thermal mass, and water has a great ability to absorb heat and hold on to it. In fact, it also means that water changes temperature slower than the air does. Okay, and so the ocean, being this huge mass of water, much of it which is cold still, is a big sponge of heat, and it absorbs all 93% of the heat that is trapped in the atmosphere. Well, why should we worry about that? Well, the reason we should worry about all that heat in the ocean is because it tends to speed up the melting of ice that is floating in it. The North Pole, the geographical North Pole, the axis around which the world spins, is not located above a landmass. Greenland is close, but it's not there. If you were to slug dog up or move, travel to the North Pole, and you had the right equipment, you could drill a hole in the ice, and what you would find once you drill through the ice was ocean. Okay, it's floating. Now, all that water that is warming up, all that 93% of the heat that is being absorbed by the ocean, is melting the ice from below. The increase in temperature of the air is melting it from above. So the ice is getting thinner, its extent is becoming less. This is the Arctic sea ice minimum, the summertime minimum extent of ice in Arctic Circle last year. The yellow line here is the average between 1981 and 2010. And in 2020, it wasn't very much. We had lost a lot of ice that year. Now, going back to this, when you have an intact piece of ice with snow on it, whatever light shines on it in the Arctic summer, much of it tends to reflect off. and go back into space where it troubles us no more. Dry snow is over 80% reflective. Scientists say it has a high albedo. Albedo is an important concept. When you melt that ice and snow, then you have open water. Open water is not so reflective. In fact, it only reflects less than 10% of the light hitting it, and it absorbs the rest. So here's what happens. The ocean is warming, causing the ice to melt. The ice is melting, replacing reflective surface with absorbing surface, and that causes more of the solar radiation to shine on directly on the water, warming the water, and you have a positive feedback system. Okay, the things that happen in climate are not linear. They're not happening in a straight line. They're curving up or curving down or curving whichever way they go, but they're not going in a straight line. Now, Greenland, I spent 13 years in Alaska going to grad school, and I've been to a lot of places around that state, but I've never been to Greenland, which is on the other side of the Arctic. Greenland is a big island that's got a thick ice sheet on it. In fact, the ice age, which once covered where we are now with a mile thick layer of ice, this is the last piece of it. That ice sheet here pretty much had melted by about 16,000 years ago. But there's still a piece right there on that island, but it's also melting. It's melting because the ocean comes in contact with on the edges is warming up, the air is warming up, dust and soot are being deposited on the ice, making it less reflective, and so on. It's melting fast from our point of view, although there's still a lot of ice there. If we were to melt all of Greenland and all of Antarctica, which is the larger chunk, you would raise sea level up to the chest on the Statue of Liberty. We're not there yet. We're not going to be there in our lifetime, but it is something that could happen in the future. Antarctica is the largest of the big ice cubes. It's the big freezer in the world. You know, it is unlike the North Pole, it is on a continent, so that if you were at the South Pole and drilled down, you'd hit rock eventually. Okay. There is two bits of Antarctica. West Antarctica is a smaller piece. East Antarctica is the bigger piece. The question is, if you're staying at the South Pole, which way is east and west, and it's arbitrary. But this peninsula here on the upper left is pointing at South America. So that kind of tells you, where things are in relation. Now, those areas that are blue, colored in blue around the edge, are gaining some ice, but they're gaining small amounts. Those areas that are orange and kind of purplish on the other side over here are losing lots. So that if you add it all up, we're losing a lot of ice. There is a particular, there is a particular area that is called the Thwaites ice sheet that is here on the western side where it says Mary Bird Land. It's somewhere around the Mary, okay? And that bit, if it were, it is becoming, it's melting, it's becoming unstable. If it were to break up and flow into the ocean, it would raise sea level about 2 feet. Now, 2 feet doesn't seem like very much to me up on my hilltop in Bethel. It would take a flood of biblical proportions to reach my house in Bethel. However, 2 feet's a big deal if you live closer to the coast. Think about Florida. Think about those parts of New York City and Boston, which are low elevation. Think about where the poor people live in the world, such as this area in Bangladesh. Bangladesh is a country that maybe half of the country is a big river delta. And this area has 16 million people within a meter of sea level. That is, for 2 feet to them, is a big deal. It's the difference between whether they can stay where they are or they have to move. There are a lot of areas in the in eastern part of North America which are quite vulnerable. If you look along the coast, much of the southern coast of Louisiana is already becoming unstable and is likely to be gone maybe in our lifetimes. Okay, the map of where that we used to see of Louisiana is not that shape anymore. Southern Florida is also vulnerable, not only to sea level rise causing floods, but saltwater intrusion on the drinking water supply, which makes that water unpotable. If you move up towards, in our area, the Delmarva Peninsula is low elevation. New York, Washington, D.C. is vulnerable, particularly in the touristy areas where we go and visit the monuments, and so on. There are parts of New England which are quite vulnerable. Miami Beach, Florida is a long island on the eastern coast of the state of Florida, on the side where hurricanes often come. And it is on an area of geology which has got lots of holes in it. So the water will just move right up through the rock in flood areas, which are quite expensive real estate. And those bits of quite expensive real estate are in danger. The flood insurance program that keeps them insured is almost out of money. And if the buildings are not insured for flooding, are the mortgage companies going to issue mortgages for them? And if not, how much are those properties worth? It's going to be an issue. It is an issue now. There are a bunch of areas in the world, those areas in brown, which are considerably drier than they were just a few decades ago. Parts of West Africa are in pretty bad shape. There are other areas which are a lot wetter than they were a few years ago. Generally speaking, in the 48 states of the US, not counting Alaska and Hawaii because they're really different, it's getting drier in the west and wetter in the east, which you can see from this map. What we have in store, whether it affects us directly in Connecticut or not, what we have in store is hundreds of millions of climate refugees in the world. They're already started. You know, many of the people who are moving up here, trying to move up here from Central America, are doing so because it's become too dry to grow crops and feed their children. Climate refugees were not strangers to it. Back in the 30s, there was an area of the southern plains which became so dry that the wind blew the topsoil away and it became the Dust Bowl. This was unfortunately right in the middle of the Great Depression, so it was a double whammy for these folks. And a lot of these folks lost their farms and basically had to be migrants. They became climate refugees trying to get into California, and California was not necessarily happy to see them. If you read The Grapes of Wrath, or you've seen shows about the Dust Bowl, you know how rough it was for them back in the 30s. One thing we need to remember, because it's a moral issue, is that those people that are the least responsible for causing climate change are the most vulnerable to it. We've all heard about fires. Now, fires are a natural occurrence in areas that have a particular climate that's called a fire climate. And that fire climate is a climate of dry weather, and heat really hot times of the year, and associated also with dry lightning that is not associated with rain. And fire climate is something that is a natural thing. It's just that with the drying out in the West, more areas are drier and in a fire climate for more of the year, more frequently, so fires are more common. This is a map published in the New York Times this year. Those areas in the red have far more fire weather days when fires could start during the year than they had before. My concern. California, look at the parts of California. And it's not just the burning of trees, but it's also putting smoke in the atmosphere, which causes people with lung diseases and lung problems to suffer even more greatly, including anybody who's got COVID. There are a number of infectious diseases which will increase as the world warms, that some of which we have had for a while, and they'll just become more common. And some of them are new things that haven't been here in a long time, if ever. And then there's this thing that we've all been dealing with for a long time. COVID is what is called a zoonosis, and that means it's a disease that has jumped from animals to humans, who are animals after all. And there's a number of diseases that have done this, and it's very common. Pneumonia, or influenza is a zoonosis. It typically jumps from farm animals, pigs and chickens and ducks and things like that, to humans at certain times. The big 1918 influenza was something like this as well. And as the human population gets larger and we start moving into areas with which is wildlife habitat, we'll come more in contact with them and be more chance of zoonotic diseases than jumping over to us. So that's a concern. But there's hope. It's not all bad news. It's a lot of bad news, but there is some hope. And there's hope in the fact that the youngsters in the world, a whole bunch of them, some of whom are famous, like Greta here in the center in the purple jacket, a lot of them you've never heard of, who are aware of what's happening, and they are doing their best to hold the feet of our leaders to the fire, and trying to get them to act in a way that benefits the long-term future of our children. And these young climate activists, they're just kids, but they see things more clearly than we older folks do, and they have their heads on straight. They're trying to help the world. And so there are things that we can do as individuals. There are other things that must be done by larger groups just because of the scale. One thing you can do is you can support those kids. You can figure out what your values are and vote according to your values. You can speak up with your voice, your time, your money. You can be active in state and local affairs. Any of us can do this. We can burn less carbon. We should do that, which means electrify more of our energy and purchase our electricity from renewable sources. We have that option in Connecticut. Okay, you can choose where your electricity comes from. You have to talk to your electrical supplier and then choose one that is coming from wind and solar and hydroelectric or whatever you want. Okay, you have that choice. We can eat less meat, which would make us healthier and reduce the emissions of methane. There's things that we as a group can do, as a society, as a state, as a town, as in this, in groups, and that is we can educate our children about climate change. We can support climate education in our schools. We can cap all the zombie oil wells. There's a whole bunch of oil wells that have not been closed down responsibly by the people who ran them. They just left them open when the oil was gone and let methane, which is a very strong greenhouse gas, come into the atmosphere. Those should be all capped. You and I shouldn't have to pay for it either. Okay, but we need to eliminate the subsidies that go from our government to fossil fuel companies. We should not pay them to poison us. We should find better technology, like in refrigeration and air conditioning. The gases we use are very strong greenhouse gases, and we should replace them with less dangerous ones. And we should educate all the girls in the world, make sure that family planning is available to all women in the world. That doesn't seem to be related to climate change, but it is related to human population. And we need to, gently as possible, slow the growth of our human population. And the best way to do that is by educating girls. I have daughters, so this is an emotional thing for me. There was a French novelist named Albert Camus who was writing about a plague, a pandemic, fictional, and he had his main character is talking about how the plague would be dealt with. And the character says, I have to tell you this whole thing is not about heroism. It's about decency. It may seem a ridiculous idea, but the only way to fight the plague is with decency. And so what I say to you is that the way that we can fight COVID and the way that we can fight climate change is with decency, human decency. So one thing we can all do is be compassionate. We can teach our children to be compassionate, and we can demand compassion from our elected officials and the policies they enact. Because the other moral imperative of climate change is that the effects of climate change that we are seeing, we made them, we did it. How many times did our children, or did we tell our children to clean up their own mess? Well, our children have every right to turn that around on us and tell us to clean up our own mess, because it is our mess. And so we need to act quickly and decisively to slow the damage. We owe that to our grandchildren, and I have a grandson, so this hits home. So we need to stop. We need to stop and think. Okay, stop and think, and think about what we're doing to the world and what we can do to stop it. Because climate change is real. It's us, no doubt. The experts agree it's bad, but there is hope, but there isn't much time. Abraham Lincoln in 1862, during a crisis of a different sort, said, the dogmas of the quiet past are inadequate to the stormy present. The occasion is piled high with difficulty. We must rise with the occasion. As our case is new, so we must think anew and act anew. We must disenthrall ourselves, then we shall save our country. And we shall save our world. I would be glad to take questions if there was some efficient way to send them to me. If you want to type them in, I can answer them verbally. You are you're welcome to give anybody, any of the other two people, my email, and they can ask me questions that come to them later on. I'd be happy to. I'm just up the road from you.
Certainly. Does anyone have any questions of what Dr. Wagener has spoken about?
So I can entertain questions that you type in the chat, or you can email them to me. Let me type my email address. I want to thank Amanda and Joni for showing up and sitting through this kind of odd way of delivering this talk.
Thank you so much. So if anyone doesn't have any questions right now, I guess we can just call it a night and say thank you to Dr. Wagener. If you just want to maybe just type that in and we can call it a night.
Well, invite me back sometime. We'll try it again and try to do the and I have a lot of material. I teach 4 courses on climate change, and if you want one that's specific to public health or specific to sea level rise or whatever, you just let me know and I'll put it together for you. Okay. Okay. All right. See you later. Bye.